Hello Cloud Pedagogians, welcome back to Cloud Pedagogy. In coming sessions, we will be exploring all different types of databases in AWS. Before going into the database section, we'll first explore our student directory application. The student directory application that we have been building out lets you keep track of student data like their name, location and job title. The app supports adding new students, viewing existing students, as well as editing and deleting students. All of this data will be stored in a database, which we haven't created yet. According to the architecture diagram we have chosen, DynamoDB is used to store this data. But we can also think, why not to use Amazon Relational Database Service or Amazon RDS is used to store this data. So let's talk about databases for a moment. Relational databases are widely used across all industries, and it's likely that your company has many databases supporting a variety of applications and solutions. You can install, operate database applications on Amazon EC2 instances. And this is a good option for migrating existing databases in AWS. By running databases on EC2, you are already simplifying things from an operational perspective when you compare it to on-premises. And it's also a very common use case for EC2. When migrating a database from on-premises to EC2, you are no longer responsible for the physical infrastructure or operating system installation, but you are still responsible for the installation of the database engine, the setup across multiple availability zones with the data replication in place, as well as the database server management tasks, like installing security patches and updating database software when it is required. So EC2 makes it easier, but there is a way to lift even more of the operational burden of running relational databases on AWS. What if instead of managing a database on EC2, you can use one of the managed AWS database offerings like Amazon RDS? The big difference between these two options is, instead of taking care of the instances, the patching, the upgrades, and the install of the database, AWS takes care of all that undifferentiated heavy lifting for you. The task that you are then responsible for is the creation, maintenance, and optimization of the database itself. So you are still in charge of creating the right schema, indexing the data, creating stored procedures, enabling encryption, managing access control, and more. But all of the rest of the undifferentiated heavy lifting that goes into operational relational databases, that will take care of by AWS. To start off the lessons on databases, we will dive into the history of enterprise relational databases and explain what relational databases are and how they are used. First, we'll understand the history behind enterprise databases. Choosing a database used to be a straightforward decision. There were only a few options to choose from. In the past, you likely considered a few vendors and then inevitably chosen one for all of your applications. Businesses often selected the database technology they were going to use even before they fully understand their use case. Since the 1970s, the database most commonly selected by businesses was a relational database. So what is relational database? A relational database organizes the data into tables. Data in one table can be linked to data in other tables to create relationship, hence the relational part of the name. A table stores data in rows and columns. A row, often called a record, contains all information about a specific entry. Columns describe attributes of that entry. The most common type of relationship cardinality is a one-to-many relationship. Here is an example of two tables in a relational database. The first table is employee table with the columns employee ID, first name, last name, hire date, manager and department ID. The other table is department table, which contains the department ID and names or the columns for the table. Consider the relationship between the employee and department table in the figure. The common column is department ID. One individual department ID can relate to many rows in the employee table. This represents the business rule that one department can relate to one or many employees. Basically, the common column creates a relationship between the tables. The tables, rows, columns and relationships between them is referred to as a logical schema. With relational databases, a schema is fixed. Once the database is operational, it becomes difficult to change the schema. This requires most of the data modeling to be done upfront before the database is active. So that's about the relational database. Next we'll see what is a relational database management system is. A relational database management system, which is RDMS, lets you create, update and administer a relational database. Here are some common examples of relational database management systems like MySQL, PostgreSQL, Oracle, SQL Server, Amazon, Aurora. You can communicate with most RDBMS by using structured query language, which is SQL queries. Here is an example. Select asterisk from table name. This query selects all of the data from a particular table. For example, if you want to select data from the employee table, you will say select asterisk from employee. This query selects all of the data from an employee table. However, the real power of SQL query is in creating more complex queries that let you pull data from several tables to piece together patterns and answers to business problems. For example, querying the employee table and department table together in a relation for the whole data, this can be made possible by a join, which we'll talk about the next topic. So, what are the benefits of using a relational database? There are many benefits to using a relational database. I'm going to discuss only few of them here. Joins. As I have already mentioned, you can join tables, enabling you to better understand relationships between your data. Reduce redundancy. You can store data in one table and reference it from the other tables instead of saving the same data in different places. Familiarity. Relational databases have been a popular choice since the 1970s. Due to this popularity, technical professionals often have familiarity and experience with this type of database. Accuracy. Relational databases ensures that your data is persisted with high integrity and adheres to the ACID principle, which is atomicity, consistency, isolation and durability. These are the few benefits of using relational databases. We will see the use cases for the relational databases. Much of the world runs on relational databases. In fact, they are at the core of many mission-critical applications, some of which you may use in your day-to-day life. We'll see the common use cases for the relational databases. Applications that have a solid schema that doesn't change often, such as lift and shift applications that lifts an app from on-premises and shifts it to the cloud with little or no modifications. Applications that need persistent storage that follows the ACID principles, such as enterprise resource planning applications, customer relationship management applications, commerce and financial applications. So that's about the RDMS concepts. Now our next step is to choose between unmanaged and managed databases in AWS. If you want to run a relational database on AWS, you first need to select how you want to run it, like the unmanaged way or the managed way. The paradigm of managed versus unmanaged services is similar to the shared responsibility model. The shared responsibility model distinguishes between AWS and customer security responsibility over a service. Similarly, managed versus unmanaged can be understood as a trade-off between convenience and control. In on-premises database, let's say you operate a relational database on-premises, means like on your own data center. In this scenario, you are responsible for all aspects of operation, including the security and electricity of the data center, the management of the host machine, the management of the database on that host, as well as optimizing queries and managing customer data. You are responsible for absolutely everything, which means you have control over absolutely everything. In the unmanaged database, now let's say you want to lift some of this work to AWS by running your relational database on Amazon EC2. If you host a database on Amazon EC2, AWS takes care of implementing and maintaining the physical infrastructure and hardware and installing the operating system of the EC2 instance. However, you are still responsible for managing the EC2 instance, managing the database on that host, optimizing queries, and managing your data. This is what is often referred to as the unmanaged database option on AWS. AWS is responsible for and has control over the hardware and underlying the infrastructure, and you are responsible and have control over management of the host and database. In the managed database, for example, if you want to shift even more of the work to AWS, you can use a managed database service. These services provide the setup of both the EC2 instance and the database, and they provide system for high availability, scalability, patching and backups as well. However, you are still responsible for database tuning, query optimization, and of course, ensuring that your customer data is secure. This provides you ultimate convenience, but you have the least amount of control compared to the two previous options. So that's all about the relational databases, database management systems, and how to choose a particular database in AWS. I hope it's not too long before we see again in my next video. Until then, take care.